Okay, today we're going to talk about an angle and what an angle is. But before we get to that, we're going to remember what we've done already. And we talked about lines. We talked about two kinds of lines in particular. This one, hopefully you're all thinking in your head, is a perpendicular line. And they cross, they have an intersection. This set of lines are called parallel lines, and they will never cross. So angles are formed when lines cross. So here's an angle, here's an angle, here's an angle, and here's an angle. These parallel lines won't cross, so they will never form angles. All right, so let's look at some angles, okay? And actually, I am going to draw right here a couple. Let's see, here's going to be a big one. And here's one that is a corner angle. Okay, so the space between these two lines, that is what is called an angle. So this space in here is the actual angle itself. Okay, and mathematicians, and those are the people that study math, have names to describe different angles. Okay, there are, let's look, there are three different kinds of angles that we are going to learn about today. They are right angle, acute angle, and obtuse angle. The right angles are called square. They have square corners, okay, and they measure 90 degrees. Okay, and so here is our right angle right here. And usually they have this little symbol. If there's a square symbol inside the angle instead of a more rounded symbol, that is your clue. That is a right angle. That is what that symbol means. Okay, an acute angle right here is one that is less than 90 degrees. So this right angle measures 90 degrees perfectly if you have a special tool called a protractor. This is less than 90 degrees. So this angle it's less than in here. Okay, so acute is less than 90 degrees and obtuse is more than 90 degrees. You see how this angle was kind of, widened. It's like you took a right angle and kind of pulled it down a little bit. And that's what makes an obtuse angle. It is greater than 90 degrees but less than 180, because 180 degree angle is a straight angle. And that's not something we're going to talk about today. So we're not going to talk about this one, or this one. Our main concern is going to be the acute angle, the right angle, and the obtuse angle. So take a second to look at those. And I want you to go ahead then, and I want you to use your fingers to show what a right angle would look like. And so if you're doing that, your fingers should look like this. So this is the part of my hand that's forming a right angle. Okay, I'd also like you to go ahead and look around the room where you're in and find some examples of some right angles. I'll show you some examples I have. Whoa, let's see. I have this example of an envelope. You see the corner? It's a perfect right angle. Okay, let's see. We also I have a package of stickers here. And the ends of this sticker page is a right angle. Okay, the corner of my desk is a right angle. You can't see it right here because it's all covered up, but the corner of my bulletin board right here is a right angle. Okay, the corner of my ruler right here. Oops, sorry, I'm making you guys sick moving this stuff. The ends of my rulers are right angles. Okay, so I want you to take a second and look around your room, and I want you to identify 3 right angles. Okay, now that we have a really good idea of what a right angle is, I want you to notice let's talk about an acute angle, okay? So if a corner angle is a right angle, then an acute angle is going to be an angle that is less than that. The angle is smaller than that of a right angle. Okay, and do you see any acute angles in this room or in the room where you're at now? Okay, so I found some acute angles around my house. Hopefully you were looking as well. One thing I actually found this in my trash. It was actually a folded piece of paper. And I know it's acute because if I take something that is a right angle, like the corner of this piece of paper, and I stick, oops, I just have a problem with these webcams. Okay, if I take you see my right angle is right here. Okay, I'm going to do right here. And if I take this angle and I stick it in there, do you see how it's not as it's inside of my right angle? Okay. I also have my kitchen tongs. You see the angle. Here we go. Here's the angle. So right here. So this angle is shorter or it's smaller than a corner angle. So if I stuck my corner angle here, again, it's can't see that. It's inside of it. Okay. I have one really tiny one. Do you guys see this brad? Probably can't even see it. My hand is behind it. It's one of those paper brads that you can cause things to stick. That has an acute angle. And also, I actually found a lot. My stapler, this inside part here, so I can open my stapler to be obtuse. See, that's bigger. If I put my right angle here. Okay, I'm using my folder now as my right angle. I think it's a little easier to see because it's colored. But if I have my stapler and it's just normal, that this is an acute angle, the inside of my stapler. I can make it when I want to put something on the wall though, it becomes an obtuse angle. You see the angle in here now is bigger than 90 degrees. Okay, well hopefully you guys will be looking around. Okay, hopefully you guys will be looking around your house to find some examples of these kinds of angles. Okay, but before we do that, we're going to go ahead and we're going to take out your master 3-127. And that is right here. Okay, and I need to make my screen bigger. Okay, so here we go. So we have a bunch of angles here. All right, and it says you're going to use scissors to cut apart the angles. And when you finish cutting them apart, and I think it means you're not going to cut the angles, but you're going to cut these squares apart. And you're going to sort them into either acute, right, or obtuse. Okay, so let's go ahead and we're just going to go ahead and identify these together. And then when you're done, you can cut them and sort them yourself. So this angle, angle T, what kind of angle do you think that is? Do you think it's acute, so smaller than 90 degrees? Obtuse would be bigger than 90 degrees, or right angle would be the perfect corner angles. Okay, so this one is actually going to be acute. Okay, and this angle right here, angle O, that one, hopefully you said, is a right angle. And angle B. Okay, angle B is kind of hard to tell. When I want to know for sure, I take a piece of paper or something I know that is a right angle and I lay it on one side of the line. And if the other side of the angle is outside of my right angle, then I know it's obtuse. And I just did this, and that is obtuse. Okay, angle R. Okay, and sometimes it's really close. So sometimes I'm going to take a corner of a piece of paper again, and I'm sticking it on here. You can see because my computer's making noises, or is making marks, and it fits perfectly in the corner. So then I know that that is a right angle. And I can tell by looking at you that that is smaller than my right angle, so I know that this one is acute. Now angle I, that looks bigger than a corner, and again, if you don't know, stick a right angle, stick a piece of paper in there, and have it line up with one of the lines, and if it's outside, which it is, that one is obtuse. Okay, let's look at the next set. So we have M, angle M. I'll give you a second. Is it acute, obtuse, or is it right? This one is going to be obtuse. Yes. Not letting me draw here. That one's going to be obtuse. Okay, angle L is also bigger than a right angle. It's going to be obtuse. Angle A is pretty simple. Which angle is less than a corner angle or a right angle? That would be acute. Okay, angle E. This one is a tricky one. It is just a little bit less than a right angle. This, let's see, that wasn't very straight. If I went straight up here, that would be a right angle, and so it's just a little bit inside. So this one's going to be acute. Angle C is smaller than a right angle, so it's going to be acute. And angle P, whoa, that's much bigger than a right angle. So this is going to be obtuse. Okay, good job. Let's go ahead and get started on side A. All right, you guys should know by now how to do your line segments, so make sure that you are doing that. There are 26 weeks in half of a year. How many days are there in 26 weeks? So our number sentence is going to be 26 weeks times there's 7 days in a week. Okay, so we're going to have to do 26 times 7. So we know we're going to take 7 times 6, it's 42. We're going to put the 2 down, carry the 4 over. 7 plus 2 is 14, or 7 times 2 is 14. Then we add this number up here. 14 plus 4 is going to be 18. So our answer is 182 days. Oops, 82 days. Okay, so let's talk about, so circle the shape with the perimeter of 14 centimeters. Color the shapes with the areas of 12 centimeters. Red. Okay, so we're not actually going to do this because it's too hard to measure on a computer. But the perimeter is the distance around, so go ahead and do that. And the area is the amount of space that is covered in here. So to find the area, remember you take length times the width. So when you measure, you're going to have your length and your width, okay, and you're going to multiply them together. Okay, so go ahead and do that. All right, label each angle acute, right, or obtuse. Okay, this one, I like to start with the right angle. This is a right angle, and I'm not going to write the whole thing. This is bigger than 90 degrees, so it's going to be obtuse. And this is smaller than 90 degrees, so it's going to be acute. This says show 11:29 on the clocks. So we know that every time we're at a number, it's 5 minutes. So we have 5, 10, 15, 20, 25. The little numbers are 6, 26, 27, 28, 29. So I'm going to go all the way down here. And it says 11:29, so it's going to be after. What time will it be 1 hour from now? So if it's 11:29 a.m., then it's going to be 12:29 p.m. in 1 hour. Okay, a multiplication problem for this picture is going to be, you have 3 groups of 6. So it's going to be 3 times 6 equals 18. And the division would be 18, because that's the total number, divided by 3. And the answer would be 6. Okay, and I'm going to have you go ahead and work on these on your own.